Welcome to Conceptual Cambridge. Today we are going to cover circular Meyer. So let's begin. So let's begin with radians. So 1 radian is equal to the angle subtended by an arc at the center of the circle whose length is equal to the radius of the circle. So what this basically means is that radian is the angle when arc length is equal to the radius of the circle. This is all that it means. So let's try and find out the angle. So for arc length, you have already studied this formula in IGCSE. Theta over 360 into 2 pi r, and arc length is r. So we can divide both sides by r and we will get this. So 2 pi theta over 360 is equal to 1. So we get 2 pi theta is equal to 360, and theta is equal to 360 over 2 pi, and this gives you the answer of 57.3. So this is what the radian is basically, and this will be used throughout this whole chapter. You can just memorize this. Pi rad is equal to 180 degree. This will make everything very simple. Moving on, let's discuss the arc length now. So, as I already told you, you have studied in IGCSE that theta over 360 into 2 pi r is your arc length, and theta should be in degrees. So, what is the arc length? So, for example, I draw a circle like this, and I make something like this. The arc length is the length of this. So, for example, when you take the circumference of a circle, which is 2 pi r, you are taking the distance around the circle, this distance, which is basically the arc length of the whole circle. What you're doing is just inputting it into the formula 2. This is 360 over 360 into 2 pi r. So as you can see, you will only get this 2 pi r, and same for the semicircle, you get 180 over 360 into 2 pi r, which is 1 over 2 into 2 pi r, which means you can cut this out, which means pi r is your arc length for semicircle. So, and now let's discuss the formula in radian, which is r theta. So as I already told you that uh, 180 degrees is equal to pi rad. So for example, let's say we have theta over here and x rad over here. So now to find this theta, what I'm going to do is 180x over pi is equal to theta. So this is what you have when you have it in radians. Now if you input this into the formula, which is 180x over pi divided by 360 into 2 pi r. So now you can just cut it out. 180 and 360 will be cut out. So this gives me 1 over 2, and you can also cut pi and pi out. So you have x over here, x in the numerator, and also into 2r. So you can also cut this out. Now you have xr. The x is the theta when you have the theta in radians. Always remember this. So what this means is r theta. Now moving on. Now let's discuss the area of a sector. From IGCSE, you know that theta over 360 into pi r square is the area of a sector when you have theta in degrees. Now, first of all, what is a sector? So, for example, I have something like this. This whole thing is my sector. So, for example, when you take pi r square, You are considering the whole circle, which is basically 360 over 360 into pi r square, and this cancels out. So the whole circle is considered as the sector over there. So this just comes from that. So now how did I get it in radians? It's the same way for arc length, pi rad 180, and now I need theta, which is over here in this x rad. So 180 x over pi is r theta, and just inputting that 180 x over pi divided by 360 into pi r square. Pi can be cut, and this can be 1 over 2 into r square x. X is the theta, so 1 over 2 r square theta. This is where it comes from, and this is going to be very useful in this topic. Area of triangle is going to be very crucial in this topic, and you should have already studied this in IGCSE, but in case you haven't, let's do this again. So you already know that 1 over 2 base into height is the area of a triangle when there is a right angle triangle. But this also comes from this formula, 1 over 2 base into height into sine of c. So basically for this, the c is just 90 degree, which gives me sine 90, which is 1. Hence why I have 1 over 2 base into height. And this just comes from the fact that if I have a rectangle over here, let's say this is the height of the rectangle and this is the base of the rectangle, you know the area of the rectangle is height into base or length into width. You already know this. So now I can divide this into two parts. This will be a right angle triangle and this will be a right angle triangle. So from this you can conclude that area of two triangles, right angle triangles, is equal to area of one rectangle. So basically, if you know the formula for the rectangle, which is height into base, you can divide it by 2. So height into base over 2 is the area for one triangle. So hope you understand this. Now let's move on. Alright, so now let's end the video over here. So remember, for this 180 degree is equal to pi rad, and also these formulas will already be given to you in the formula sheet, so you don't need to memorize them. Alright.